I'm at Amoroso from Tag Cyber, and I'm here with a longtime friend, John Viega, who is the founder and CEO of Capsule8 right here in New York City. Hey, John.
Hey, Ed. Thanks for having me.
Thanks for coming by. It's going to be fun to hear about what you guys are doing in production Linux and some trends you see, but why don't you share with the folks watching just briefly what you guys do at Capsule8, and then we can dig into the technology.
Yeah, sounds good. At Capsule8, we protect modern Linux infrastructure, whether it be on cloud or containers or in the data center. And we do that with a runtime security that protects against everything from 0 days to more mundane TTPs, misuse of your systems. Like we catch a lot of people doing things they shouldn't be doing, like debugging in production, for instance.
So production Linux is that's where you guys
100%, and we are kind of focused on every Linux environment in a way that is very easily portable across them and doesn't put any risk to the operational environment, and that's a very big deal for our customers. The way we got started, I mean, there are a bunch of different origin stories, but one of the big ones was my last company got acquired and I ended up picking up a large managed security services provider in Europe and had a bunch of companies saying, hey, can you do some EDR for our production Linux infrastructure?
EDR, endpoint detection response.
Endpoint detection and response. And we thought, yeah, that should be easy. All these EDR vendors have Linux products, and we tested them all out and started pilots with a couple of these customers, and they all had the wrong model. They drove up operational costs. They would crash busy systems and
slow things down.
Slow things down, and all the trials we did, the partner customer said, no way, take this thing out. And that was kind of one of the seeds for the company. And when we started, and I started interviewing people that are CISOs in large companies asking about their Linux footprint and how they expect that to move to cloud and containers, we heard a lot of the security forward companies saying the same thing. We really feel like there's a problem to be solved here, and we've tried a bunch of different EDR solutions and can't make any of them work for us. So instead, what happened was they started focusing on investing more in the SDLC, like the assurance of what they put into production, because that's the only thing that didn't come with a massive amount of operational risk. So.
You know, it's funny, but for me personally, I spent a lot of my career securing operating systems.
Yep.
And in the early days, it was procedural. You'd buy these books, or you'd get these manuals, or you'd apprentice with someone.
Right.
And it was this craft of how you configured and managed and administered. In those days, we'd say a Unix system, I'd say Linux. But
right.
What's sort of the balance? Because I'm imagining that with Capsule8, there's still probably some manual things you need to do. But what do you recommend to people? Do you just install Capsule8 and you're good, or is it what's the process of securing an ecosystem?
It's a good question. So we have kind of a couple of different call it packagings. One we call, or I call, the IPS packaging, which means detection in real time and protection for stuff that we're really confident our models are so accurate that you could just kind of fire and forget. Like you don't have to configure it, it works the same everywhere. And then there's the policy capabilities, which are much more environmentally dependent. You know, what the workload is. You can't kind of generically say how the file system should be used across all workloads everywhere. You can say generically how the kernel should be used in all environments everywhere. And so that requires some configuration and tuning. And so some of our customers just use like the IPS version. Some customers just use the use both, and but
would an example be like if an environment was supporting real-time apps versus non-real-time? Is that an example, or what, I'm trying to think of what some of those differences might
Sure.
be.
Well, like, a good example would be, think of like a network security policy where you want to, we really try to find attacks while they're happening, and that's kind of our preference. But you can also do things like compare your threat feed against like inbound network connections, right? And that in many workloads is a spammy, noisy, like, because you're handling all these connections from all over the world, and so do you really want to deal with that kind of problem? And then for file integrity monitoring, for instance, we could have, like, if you look at something like the MITRE ATT&CK framework, and it says, well, here are all these indicators of post-exploitation that you should be looking for. Many of those things will false a lot in some production environments, not everybody's. Like, for instance, saying, well, if you look at the, if somebody's exfiltrating data out of the Etsy shadow file, for instance, and so that certainly could be a rule that works like in every environment in one company. And in another company, it may be that their tooling goes in, and when they add a new user to the system, it goes in and changes the Etsy shadow file.
Or like a lot of bad apps
cluster.
do go in and touch Etsy shadow in particular, which they shouldn't.
Right, exactly. And so, we make it really easy, where no one else has ever done this before, to make it easy to say, hey, yeah, these are the actual valid ways to do these things on the file system or on the network, but that does require some configuration, as opposed to like an IPS world where, we know that like when somebody's like exploiting the kernel or launching a command injection attack, that's like almost certainly bad, right? And you're not going to see a lot of falses, and you don't have to do a lot to configure it. If that makes sense.
Now, you mentioned file integrity monitoring. You guys basically have kind of reinvented or solved that issue. You guys do a pretty good job there.
Yeah, the traditional file integrity monitoring product, we talk to a lot of enterprise customers who say, well, I have to do it for compliance reasons.
Right, it is a requirement in a lot of frameworks.
And yet we don't get any value out of it. We never use any of the alerts. And when we drilled into why that is, it turns out to be because file integrity monitoring products don't give you a lot of context for the alerts, because they don't have it. The operating system doesn't provide it to them. So if you have a file integrity monitoring policy, something really common would be no executables on the system should ever change. And that sounds pretty good until you realize that in most production environments they change all the time, because like you do a system update because you're worried about all the security vulnerabilities on that system. And then when the system update happens, file integrity monitoring products say, like, here are 150 executables that got changed, and your SOC gets flooded with 150 alerts, or whatever the number is, times the number of systems that you're updating, right? And so the threat actors aren't idiots either, and they know that if they're going to make file system changes for persistence, you're bound to do an update, and they can just kind of wait for that, make their changes, and even if it does alert, you're probably never going to notice it. And so we solve that problem quite cleanly, because we create like the operating system doesn't provide a lot of context, but we kind of get like inside the internals and create that context so that we can make really simple policy decisions, like, this is how we update our system. That's allowed to change executable files, nothing else is allowed to. So if you manage to change an executable some other way, then, ding, 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 we know immediately there's a real problem, but we don't alert on all the times that you legitimately update your system.
So the remaining alarms for things like executable changes would be something you can't correlate to a legitimate activity log or
Right.
some event in a transaction log.
Right.
That is a good idea. I mean, it still might be some false positives. It would be way low, way fewer.
Yeah, and then when you see them, you get all the context to say, well, oh, I didn't realize, I thought all our updates happened through Puppet. I see that on this kind of system, we've got Snap installed and that's doing a bunch of updates. That's okay too. And then you can essentially say if the system's Snap is installing stuff, that's okay too. And then you'll never see another false positive there either, if that makes sense. So there's so much context behind any alert that does come out of our policy capability that you can easily say, well, that's just my policy's not accurate enough, and then go make it more accurate.
It's just about every enterprise now that you talk to moving their stuff to workloads in the cloud. Is that pretty much become the de facto means for taking advantage of cloud economics?
Yeah, I think that every every company we talk to is investing in the cloud. Where they are on the adoption path varies a lot by industry. Like I'd say in a big chunk of the financial industry, they're still not as far into the cloud because of the compliance environment.
I think that's an excuse.
Well, I don't know. I mean, you're probably better positioned to say.
I don't know either.
I think here's the challenge, like the
because you can carry your controls, for example.
Yeah.
Somebody's right. Data center versus Kubernetes managed in a container somewhere.
Yeah.
Same thing. Like I'm checking the same boxes on my PCI.
Yeah, but a lot of it boils down to the auditor for many of these compliance frameworks. Like they have a lot of flexibility to say, here's where your bar is. And if you think of what they're all used to, it's this big stack of appliances. And if you want to move to the cloud, they're going to say, well, what's your replacement
Where's
for
your
your
perimeter?
IPS controls? And right. And
but I still think you can answer that.
you can, but it requires a bunch of gymnastics and could potentially put a lot of operational risk in. So until recently, there was no way on AWS to kind of tee off your traffic the way you can when you own the network. They just added this actually, but so you could put like an IPS in like software, like in a VM somewhere, but you had to kind of route all your traffic through it, which means there's just a lot more operational risk. So, the appliance was never a good place to do anything anyway. It just like the fidelity of the data was too low, and it's a big part of the problem why there's this massive amount of spam sitting in the SOC is because we're focused on gathering as much data as possible and looking at really low fidelity data instead of focusing on like taking our expertise on what the bad guys are doing, looking at the right data, and trying to get the right fidelity of data. So, but I think the financial institutions, they all have stuff in the cloud now, but it often tends to be the least mission critical bits where it's easier to jump the bar to say, hey, like I've seen a bunch of financial institutions doing like their quarterly stress testing in the cloud, for instance.
Makes sense.
Yeah.
Now, do you guys do any artificial intelligence in the processing? Like your algorithms have maybe like some machine learning assisted or similar heuristics in the code?
Yeah, we have a pretty I'd say complex thoughts about AI and data science. I mean, first we think it's both invaluable and overhyped buzzword.
Yeah, yin and yang.
Right. So realistically, we do a lot of, you call them like static stochastic models, and we started out experimenting a lot with online models with like kind of automated learning, and so like a lot of in the early days we had plenty of customers that wanted to experiment with problems that really only scale via learning, like, hey, the topology of my network, can you tell me when it changes in a way that I'm not expecting?
Yeah.
And so in a kind of, that is, it turns out to be massively noisy and wasn't of great value in practice to a lot of organizations. So especially in like this continuous integration, continuous deployment world, you're always pushing out new software and the topology of your network could change all the time. And then what are you even baselining against? Are you baselining against the 29 versions from the past month, or are you re-baselining every day, in which case you're not going to get anything interesting anyway? For us, our models are things that are, I mean, right now everything is a static model and kind of universal across our customer base, and what we're trying to model is this a bad guy or not? So you're essentially trying to model the universe of all bad guy behavior, and so the question is, what are the features that kind of correlate to potential threat actor behavior? And the more expertise you drive into the feature extraction, the better results you get. So I would actually say that one of the things that most people are derisive of in the security industry are rules. Yeah. And so we say, oh yeah, well that's, that sounds like a rule. And in my view, if I could ever get to the point where a rule was 100% accurate, that's actually,
it's awesome.
Awesome, right?
And you know what? All these AI models, a lot of them are decision trees.
Right. And so that basically, like, think about this though, a rule that's 100% accurate, you're basically saying I have a model, a statistical model that only needs one variable and is completely accurate. That actually sounds awesome.
I know. I go nuts when I hear everybody say non-signature based. I get the problems with signatures, but they're talking about something different.
Yeah, they're talking about hashes.
Right.
And
that doesn't make sense.
Right.
But when there's a technique or a method that's common and you can spot it happening, somebody needs to tell me why that's a bad thing. That seems like the goal.
Yep. So I'll give you a real simple example from our world. The ideal is come up with a rule that detects something with 100% accuracy, and you're probably not going to get there because the world's too diverse a place. And then let's try to figure out what the features are that are going to help us get as close to 100%
Hence your
as possible.
stochastic view.
Right. So just to give you a really simple example, you might say, well, in most production infrastructure, there are very few ways to log into a system. In the old days, like SSH or logging in from the console, which would be Getty. And in the modern era, it might be like kube control exec or Docker exec or something like that. But
you can make a list of them.
You can make a really small list, and any other time there's someone logged into a machine, that's definitely bad. But the ambiguity there is, what does it mean to be logged into a machine? So which is really like somebody's interactively logged into a machine. And so that notion, like, you can apply your expertise on what are the indicators, like the features we could extract that say this might be interactive, and then build a model of, hey, this is interactive or not, so that you don't, and you got to be really err on the side of not raising the alarm when it isn't interactive, right? Because people get shells all the time as programmatically in a Linux system. So that's where we can really apply our expertise, build a good model, and expect that it works pretty universally. And some of our analytics are essentially regression models. Some of them are graph based. It really just kind of we start with, we can break into a bunch of things ourselves. What are the things that we kind of have to do as a matter of course? It's like the black hat toolbox isn't that large, and so let's look at anything in the black hat toolbox and say, is there a reliable, efficient way to kind of look at this stuff? Start with postulating a rule, and if that rule is 100% accurate, then you're done. And when it isn't, you say, well, what are the other things that I can correlate to kind of get the accuracy up high enough to be acceptable to us and our customers, if that makes sense.
Well, that's a lot of people would call that in their brochure artificial intelligence.
Yeah,
right?
we would never do that. And I would say most security companies aren't doing that in our experience. They are, like, when they say AI, they basically say we're going to let the algorithms do as much of the workforce as possible. So they don't bring any expertise to the table. They collect as much data as they can and hope that, like, the learning will bubble up some interesting things, and that it doesn't work very well.
I always go dig in, like with kind of clients or vendors that come in, and technology companies that claim AI. I don't have a problem with it if when we lift the hood, it's something good. There's some real computer science, and whatever, call it what you want. There's a marketing decision. But you're right, a lot of times we see these real trivial decision logic kind of code that's called artificial intelligence. That seems misleading. I was pushed back when I said that. Even a decision tree with some real probabilistic kind of decisions, that doesn't seem like AI, but whatever.
No, I know.
Hey, I want to ask you real quickly about IoT. That's an adjacency. Do you see the IoT and like industrial control world adopting Linux more? Is Linux going to find its way into that environment?
There are already plenty of IoT environments that are big on Linux.
It's free and it's easy to program too.
And you have a lot of flexibility to take stuff out of the kernel that you don't want that are still kind of necessary in a lot of constrained environments. So absolutely, I think that the traditional embedded OSs like a VxWorks are eventually going to disappear because Linux is so well suited for that environment, especially as kind of even the embedded computing power and power utilization all improves. So, I think that that for the security industry, that's probably a big positive in the long term, because it means that you have to master fewer esoteric technologies to do your job well.
Well, it's plus and minus. Like an attack can cascade.
Yeah, that's fair.
That's fair. Like sometimes that's security through obscurity, which we both hate.
Yeah.
But is still present if I've got some kooky, non-interoperable thing.
Right.
Well, I don't like it, but it's not interoperable.
Right.
So, a worm or something like that is not going to cascade into it.
Yeah.
That's how a lot of mechanized infrastructure has avoided security attacks, frankly.
Is true.
And again, you and I would preach, teach, and just argue that that's a terrible way to do it.
Yeah.
But if you are going to go all in line, everything IP, everything running Linux or Windows, then you have to protect it. You can't just let it.
Well, look, I got to say, though, that for when you're on a system, whether it's a mobile system or a kind of traditional like server or desktop, the assumption is that you've got a pretty large attack surface available to you. It's an assumption anyway. It may not always be true, but it's a general assumption. But when you're not on the device, you're near the device and you can access it over the network, it's much easier to get your attack surface to be pretty minuscule, especially if you've got any kind of authentication and authorization as the first step of communicating. Which in the embedded world, though, like a lot of times that doesn't even happen. If you're on the same network, then come on in and do whatever you want.
Or you get servers that have 11 back ends and 3 front ends and network to 80 different things. And then suddenly there's no choke point where you do authentication. You just got this thing that's connected to everything tangled into.
Yeah, and the
You see
bit
that a lot in industrial, and like a factory, or like a hospital.
Oh yeah,
With
hospitals
medical
are scary, aren't
the
they?
stuff is all connected to everything.
It's just a good thing that there doesn't seem to be a lot of financial incentive to target them, because it's generally going to be easy to get onto the networks, and everything is kind of, and often to get physical access, and yet everything's pretty sloppily done, as we've seen some evidence of with, like, hacking insulin pumps and pacemakers and things like that.
Is this a future opportunity for you guys as you grow? Because I know right now you're pretty busy with all the production Linux is everywhere.
Right.
So I know you guys have been growing like crazy.
Yep.
But I would imagine probably even accelerate.
Yeah, look, IoT is a future possibility. We also have a lot more capability that we can build on top of our platform for production Linux. I would kind of consider what we've done as a security platform to replace appliances. You could call it like a software-defined security platform, where we could build a lot of different things on top of the same kind of core technology. So those are considerations too. We do have some kind of older school companies saying, well, this is really nice, but we want to buy everything from one vendor, and so can you do Windows as well? We probably won't do that one anytime soon. But I think that when we
POSIX is down somewhere in the middle of that, right? It's at the bottom of Windows.
Fundamentally, the attacks are so different, and the
I
environment's so
understand.
different that it's like a whole new company, and there are a lot of good companies in that space. So I think that though that if you look like 3 years out, there's an explosion of possibilities for directions we could end up in. But it's hard to predict where we'll end up. I think it'll be driven by, we'll be dragged into our next markets, not kind of like pushing ourselves into them.
You're good at building and running these companies. You do a good job with it.
Thanks.
I think it's good for our industry to have people like you. A little academic background, practical. You've got the whole package. You going to still come back and talk to us when you're the next Uber for cybersecurity, or what?
I'll
still talk to your friends?
Always
All right,
talk to you, yeah.
All right, next time you come, you'll be in a 3-piece suit with...
I don't think you'll see that.
I'm guessing not. Right, probably not. But, it's always good to see you. I appreciate you stopping by. I hope people enjoyed your insights.
Thanks.
I think they will. And if they want to be in touch with you, visit your website. And maybe you guys can help them secure their Linux environment.
Excellent. Thanks, Ed. It's always great to talk.
Good to see you, man. Thanks
You
for
too.
coming.
Thanks.
And we will see you next time.